Are you enjoying your AWS conference so far? Go Remars, woohoo, all right. Also, happy Pride Month to people who are celebrating Pride. So, my name is Trish Lugtu. I am the Principal Data Scientist for Healthcare at Teradata. We'll be talking also with Chris Skrinak. I practiced that. Okay, from Amazon Web Services, and also Scott Dupertis from Teradata, who is our practice lead for manufacturing. So we're going to be talking a little bit about challenges of analytics and how we work together to solve some of these problems. We know from this survey by Gartner, where there were like 2,300 CIOs or technology execs who said data and analytics is one of the top 3 priorities that we have, behind security and neck and neck with cloud. We also know, and as we should if we are doing this in practice, we know that we can find great value from analytics. 9.5 trillion is the lower end of that estimate, by the way. It goes up to 15.4 trillion. These are big numbers. We also know that the breakaway companies, the innovative companies, are spending 25% of their IT spend on analytics by itself. So they're spending all of this money, and yet we're still finding challenges in implementing analytics at scale. 74% of organizations have not moved their big data and AI initiatives into widespread production. And then we have like 80% failure rates of getting AI to production as well. Some of those common reasons they talk about are inefficient data preparation, lack of flexibility to use the preferred tools. Don't take away my tools, I love them, I already know how to use them. So we also have it's difficult to score data live at scale. These are the challenges that we're facing out there. And so, and one more thing I'll talk about, if you follow the works of Andrew Ng, he talks a lot about, we have a lot of data, but it's not the best quality. We're really going to have a lot of success if we just pay attention to the data we have and build the quality, right? So he's talking about building data-centric AI. And at this time, I think I'm going to invite Chris up here to talk about some of the scaling challenges you're seeing at AWS.
Thank you.
Yeah.
So in my role at AWS, I get to see a lot. I'm really on the sort of the front car of the roller coaster of machine learning. But there's a few principles that I think help guide everyone onto this track without so many ups and downs. First is that with machine learning, you probably already know more than you think you do about getting it into production. Because the basic story here is with machine learning, data writes the code. You use the same agile processes, you use the same DevOps, but here's the key. Data writes the code. If you don't have data, you don't have code. And here's where the barriers really come in. First of all, there's a challenge in that we don't have enough folks that maybe just heard what you just heard, that maybe have sort of a little bit of a fear factor to get into this, and it's huge. There just aren't enough builders out there that really understand deep learning, PyTorch, all of the tools that say surround the NVIDIA ecosystem to even experiment on your own laptop. So this is a problem. And especially, there's a number of personas that need to get to this data. Everything from business analysts to decision makers to developers who maybe never even took a course in data science. When I say that data writes the code, the principal way to begin to create predictive models is with data that's already been labeled. Now, sometimes data is labeled for you. For example, in a transaction log, a customer has purchased something. Well, that's helpful. But in many instances, you don't have that label. You need manual labeling. You need assisted labeling to be able to create those predictions. Next, there's a lot of tools out there. This is an emerging field. It's not quite as bleeding edge as, say, it was 4 or 5 years ago, but there's a lot of tools out there, and it can be confusing. Version compatibility alone, once you settle on your tool set, can really be a problem. And Certainly, we write software because it creates value for our enterprise. You wouldn't be doing this in the first place unless it brought more customers, reduced churn, eliminated supply chain outages, things like this, right? So you have to put it into production. It's really all about deployment. Now with machine learning, we call that deployment ML Ops. And as I said in the very beginning, you don't have code unless you have data. So what's the difference between ML Ops and DevOps? It's the data. Data has to be versioned, it has to be tracked, auditable. You may need to keep things like personal information out of the training process. So it becomes a really cumbersome process. Now that said, we're here together today because with Teradata and Amazon, we've overcome quite a few of these barriers. So Trish, I'll hand it right back to you. Oh, you may need that.
Yes. And I think you're actually still
I'm sorry,
up.
this is
Yep.
still mine. Forgive me.
Yep.
All right, well, yeah, that's why I'm here, because I'm from Amazon. So I did mention that there are a number of personas involved in this process. So certainly business analysts. Business analysts are absolutely key. And to date, for the most part, data analytics has been creating metrics, what could almost be called a rear mirror view of your business and what's happening. The very nature of machine learning is prediction. Turning metrics into predictions is why we begin to adopt machine learning algorithms and introduce that then into our analytics. What if, for example, and this is a question I frequently ask decision makers, what is there something that if you could predict it, it would transform your business? Maybe if it's only 2 or 3 months in the future. And that begins the conversation because that's what we do with machine learning. Now, data scientists, of course, are sort of that piece that we just don't have enough of out there. And the ones that are there need to have efficient tools to work quickly, to get through that cumbersome process. We talk about big data, but that big data is not ready for machine learning. It's up to 85% still of a data scientist's time to prepare data before it can see the light of day of an algorithm, and that's only the training part. It's not inference, where you're actually using it in deployment. ML Ops engineers may not need, for example, data science training at all to be able to choose between, say, scikit-learn and PyTorch for a particular problem. But they are generally developers or DevOps professionals, and they do need to have the tools that are familiar to them to get apps into production, to version them, to blue-green test them, and make them reliable at enterprise at scale. Tens of thousands now of, tens of thousands now of customers on AWS have discovered these tools through the SageMaker family of tools. So that's everything from, of course, Amazon retail itself to all these customers that you see here now. Now, when we say SageMaker, we are really talking about a pretty broad family of tools. There's more than at least 30, perhaps even 40 now, discrete components within that. And we're going to show a few examples in a few minutes of some of those tools and how they overcome these blockers. So now, Trish, I believe it's back to you.
There you go, thank you. All right, so let me tell you a little bit about Teradata Vantage. Do we have any Teradata customers in the audience? Let me see some hands. All right, so I'm going to really introduce this well. Teradata is a company that has been around since 1979. So remember, maybe you weren't alive, but in 1979 there was no real cloud, right? So we were stuck in a box, and we got really, really good at being efficient with data. So I think that's one of our greatest strengths, is because wherever we go, we're super efficient with data. And now we're in the cloud, which means that we're going to keep our costs lower in the cloud as well. But what we call it is this connected multi-cloud data platform for enterprise analytics. And the reason, let me break down what that actually means, because it's a lot of terms put together that could mean lots of many things. It's connected, meaning we do really great integration work with our data platform. We can bring together files and data from different data sources. And we have APIs that connect. We even allow Python, or we support Python and R to be used to do SQL pushdown in the database, which I'll explain in a minute. We also integrate very well with AWS, Amazon SageMaker tools. And so it's this connected data platform. The multi-cloud part, and we're not the only multi-cloud database or data warehouse or cloud analytics platform, right? But we are, I believe, the only one who can query across clouds. Now think about that. So even if you're in AWS, and that's why we're here, if you have a sister company or other partners that are in different clouds, we could query across the data. I mean, that's mind-blowing to me. Let me point out this one part of it, native object store. Basically, we provide the native ability to query data in JSON or CSV or Parquet files. We also have the ability to write natively from the advanced SQL engine into those files in an S3 bucket. So that's think about commingling your data with files. When you're doing machine learning, we do that a lot. Our solution engineers like to say, hey, it's a cheap way to store data in the cloud, offload some of that data. But I keep telling all of them, you're forgetting about us data scientists. We love to bring in other external sources of data, and this is another way we get to do it. So this is where I get to say we have now created a strategic partnership with AWS. We've had a three-year commitment to do this, where we're both investing in the integrations that we have between Vantage and SageMaker to start, and a few other things. So I'm very excited about that. So that's like, yay, we just announced that. So let's talk about how we scale analytics. We've heard about all of the challenges. We've heard about what's stopping people from getting to, development to production. Well, let's talk about those bottlenecks, and then we'll frame up how we solve those issues. So we know they occur at every stage, these bottlenecks. And I'm going to put this in the most simple 1, 2, 3 method. We're going to prepare data, we're going to train data, we're going to deploy the model. Train the model and then deploy the model. So we know 80% of project time is spent preparing data rather than creating value. We know that it takes 5 months on average to take a model from training, development to deployment. And then it takes about, this is actually a number that I think is low. 65% of predictive models are never implemented into production. And we did get that statistic from somewhere, but it's not, in practice, I've seen it much higher. So let's focus on this one, prepare data. What can we do? How can we make it faster? So if you're not familiar with Teradata Vantage, you're not familiar with Teradata Data Labs. Data labs are these sandboxes, right? Data scientists need a place to explore their data, to bring their data together, to make a mess. Well, at least I'll speak for myself. I am messy with data. I know a few others are as well, but that's what we're there to do. We're there to look at data. We have to sometimes make it up. Sometimes we need to delete it. Sometimes we need to just try and fail. So we need a place to do that. The data labs let you do this. It's part of the data analytics platform. So if you have your data warehouse in the same platform, you already have access to that data. You don't have to bring it to another database, because we know that takes time. It takes skill. It takes a different sort of work effort than what we do as data scientists. You can also combine your data sources there. You can access that native object store that I talked about. And again, I say you can natively query this, and people tend to think that means SQL, but we support Python and R also to be able to do these things. So that's, definitely an important aspect of that. And the other piece that is, not that fun to talk about, but really important, I said I was in healthcare. I work with healthcare accounts. My experience historically has been 20 plus years of working with healthcare. Compliance, security, governance, all of that is important. They want to know who has the data, where it is, why it's being used, being accountable for that data. And this is what allows, I'll even say this is what makes compliance folks happy, to know where their data is, how it's being used, and being able to manage it, but still giving the data scientists the freedom to do what we need to be able to do with that data. Another aspect of preparing data is that historically, if you aren't in the practice of feature stores, then you're in the practice of creating an analytic data set, using it for a model, deploying it maybe, moving on, next data set, next model, and then so on and so forth. Well, we don't think that this is helping the sustainability practices for implementing machine learning at scale. We want to encourage folks to build feature stores. Now, I have a master's in predictive analytics from DePaul University. And in that program, we were not required to learn about data warehousing. I took it as an elective. Kind of blew my socks off because I worked with data warehouses just as an end user. Didn't understand why it was being built that way because it's weird. But now that I understand it, I think we definitely need to leverage this. We don't have to be the ones to build it. We can find our partners to do the ETL and stuff to do that. But this is how we can continue to make data have that sustained, that sustainability, and also the shareability and the democratization of data to bring it forward to use and reuse for models. So still in the phase 1 of the analytics 1, 2, 3 story. Now we're going to start talking about some of the data integrations with Amazon S3 buckets, because here we have on the very left, we have one scenario. Now, if you're used to just working with data, you pull data into your laptop or your shared environment or wherever you're pulling it. You're working with data there, you're creating your machine learning, and then you implement it somewhere. This is not that, okay? This is where we use either the Teradata ML Python library or the tdplyr library. And I'll probably just talk about Python because it's my favorite. So what it's doing is it's allowing SQL pushdown. Are you guys familiar with SQL pushdown? Yes, no, maybe, yes? I see one guy shaking his head. No, okay, I'm gonna explain this. So say you really love to work with Python, because who doesn't? All right, so Python is a language, it's an experience. You work with data frames, and usually the data frames are pulling the data onto your laptop. But what we're doing is we are providing this package that creates virtual data frames. And the experience to work with it is very pandas-like. It's very Pythonic. It's a very Pythonic experience. But what it's doing is it's taking that object that you're creating, the virtual data frame, and that object is holding SQL script in the background, right? It's translating SQL script in the background, and it's pushing that SQL down to the advanced SQL engine and running the data there. Great. It's returning some results that you can see, like, top 10 rows or whatever you specify. But the data is in the database, and it's in there within your session, and it maintains in your session until you either want to end your session or write it to a permanent table. But what this does for us is it makes it really, really fast. So you take that virtual data frame, you do additional manipulations, because it's a very pandas-like. We also have the methods available to pandas data frames and to SQL Alchemy. to manipulate that data. So you're preparing your data in database. We also have in-node processing, where we're actually implementing a Python or R interpreter on each database node. So you're bringing your analytics to the data. You can run that Python in the database, just natively in there. And then we can, of course, from the database, because remember, it's not on your laptop, we can push it to an S3 bucket with simple write statements, and it is fast. Because I don't know if I mentioned it, but Teradata Vantage has a massively parallel processing architecture. I will now call that MPP because it's too many words. So, but the Vantage MPP is incredibly fast. It writes that data very fast to the S3 buckets. Okay. I'm seeing a blank there, just throwing me off. All right, so here's that. Now we're preparing our analytic data set at scale. We work with customers whose data scientists might have 21 million rows in their record set that they have to work with. And I have customers I work with that have, a couple thousand. And still, it's just a seamless way to do this. So you're creating you're using your in-database functions to prepare that. And here's a little idea of what the Teradata ML Python package is built. So it's extending pandas, it's extending SQL Alchemy, and we're putting these Teradata packages around those to work well with our system. And here are just some customer benchmarks that show you why we think this is a great solution for working with your data at scale. I mean, the first example, this is a local R script sped up when you did it in database. Went from 4 hours to 10 minutes. Same with local Python script, went from 48 hours to 18 minutes. That's a pretty cool number. Even SAS, if you're using SAS, and I know you're still out there, maybe in this audience, maybe not, but incredible speeds. The thing that, faster, better, more relevant, governance, blah, blah, blah. What I love to point out on this slide is that you fail faster. Because of these efficiencies of working with the data, you fail faster. You know if something's not going to work. You know if it's not a good direction that you're going sooner. Here's just a sampling of some of our in-database functions, because I didn't even mention these yet. You can run these with SQL, write in a select statement, if you like that sort of thing. Or you can use Python or R to access these as well. I mean, think about it. Here's something where we're doing moving averages in a database. Think about that for a second. Right? That's pretty cool. And here's just some examples of the pandas-like functions that we have available for data frames. Lots of things you can do. So the bottlenecks at the train the model section. We're going to hand this over to Chris, and Chris is going to talk about how SageMaker fits in to this story.
Thank you very much. So just briefly, if you haven't trained a machine learning model in the past, we've covered data prep. And as just a reminder, most data does not come prepared to go to an algorithm, right? So you have to have that step. You have to acquire it, prepare it. Now you're ready to put it face-to-face with an algorithm. When you put it against that algorithm, it might be a classifier, it might be predicting time series, et cetera. It might be just taking image data, for example, and classifying what's on those images. So that's training the model. The output of training a model, you use an algorithm to train a model, and the language gets a little tricky here, is what we call at AWS a model artifact. And you could think of, sometimes I say it's like compiled code, right? It's not the code that you wrote, it's the compiled code. Well, the model was built by the algorithm when it met the data. Now, those model artifacts then go into production, right? And when they're in production, that's when we're dealing with all of the ML ops issues. So SageMaker supports every phase of that life cycle. First of all, we provide Jupyter notebooks that are very complementary with the tools that we just saw. In fact, that last slide with all the features for analytics, I want to use that as a cheat sheet next time I interview. At any rate, the training aspect of what happens on AWS, if you've never used SageMaker, is unique. We have a number of features that reduce cost and increase productivity. You can, of course, use a Jupyter notebook the same way you do on your laptop, but SageMaker provides actually a batching function. You can actually, when you fit your algorithm, you actually send it off to a batch where it can run on a machine of any scale. So for example, when you're using SageMaker and Jupyter Labs within the notebook itself, you want to use something that's like, 5 cents an hour or something. But if you're ready to throw a big deep learning model to heavy-duty GPUs, you might want an NVIDIA server with 8 V100 GPUs in them, $8,000 each. They're not so cheap, right? They could be $30 an hour. So you can work on that 5 cents an hour machine, send it to a $30 an hour machine for processing. Of course, it's charged by the second. And that's just 2 options. There's also batch processing. You may not need to do this in real time at all, but you're sending it off in batches. We have some other techniques where you can actually work on your own laptop, because SageMaker comes as a Python module that you can pip install. And then when you do fit on your laptop, provided you had set up everything correctly, run that in the cloud. So you have all these options. The reason that it's so easy to put all these together and get that functionality on training is the fact that we're sharing S3 buckets. So we know where the data is, we're pointing at the same data, and so it makes it really easy to take advantage of all these cost and time optimization tools. Now, deployment is key. That's why we're building these things in the first place. Tracking the data, auditing the data, having model monitors, having auditability at every step of the way is, for the most part, automatic, right, within SageMaker. So when you're using some of our model monitoring tools, you get real-time information on how those models are performing. You can capture every data that's being used for inference on that data. You also have options for maybe not having full-time endpoints in production, right? Because they can be costly. So we have serverless inference, where just on demand, you can stand up an endpoint and do inference on that. We also have asynchronous inference. Now, that might be a real-time situation where you have big data, like media data, coming in, and you need it processed in real time, but you don't want to have, you don't want to wait for it, basically. So you can launch that instance. It actually kind of behind the scenes uses our messaging protocols, SQS, to run the job, tell you when it's done, and from your code, it all looks seamless. So from build, train, deploy, and monitor, and I should also mention certain other things like getting human in the loop. We have a number of tools that are very complementary with the Vantage 1.2.3 process, where you can integrate humans in the loop with model monitoring. Of course, these days, responsible AI is a key topic, and every enterprise should have that bit covered. It really just comes down to auditability, monitoring, and making sure you have humans in the loop when data that's writing that code starts to go off course. So let's take a look at SageMaker itself and what some of these features are implemented. This is a familiar Jupyter Labs interface. If you've used Jupyter Labs in the past, these are just Jupyter Lab notebooks running Python. So if we take a look here, these are the cells which you're familiar with, running pandas here. And we could see on the upper right-hand side of the screen that we actually have a choice with just a pull-down menu to choose really 2 things. Number one, what's the kind of environment that we want to run in? If you're using Conda, for example, we have several pre-packaged Conda environments that you can just go to. That could be, once again, PyTorch. It could be R. It could be whatever it is that you need, that you're familiar with. But you can also, on a pull-down, switch the CPU you're using. On the fly, you can switch from a CPU instance to a GPU instance. So some of those are set up for fast transfer mode. In other words, you could just pull down, wait a few seconds, it's not instantaneous, and you can switch to another instance type. Now that's all in the notebook. That's what do I need in the notebook at this time to get to what I need. So in this example here, we're actually taking a look at how we're scaling to a GPU cluster. Now, as you might imagine, we have some pretty heavy-duty GPU clusters up on AWS, including the NVIDIA GPU backplane connected clusters. So we're talking about really the highest power of GPU training capabilities. So that's especially important for large language models, things like Hugging Face, et cetera. All right, that's all pretty heavy-duty data scientist stuff. And that's one persona. But let's talk about business analysts, right? We really want to democratize this data. You shouldn't need a PhD to do machine learning. And I apologize if you have one. But let's say if you do have one, you want to bring more colleagues in, right? If you want to run fast, run alone. If you want to go far, you bring a team. So that's the whole idea here of this SageMaker component called Canvas. Canvas is, it's designed for business analysts. So when you bring the data in, you can immediately do some basic data analysis. You can quickly identify bias within the data. When I say bias, what I really mean is, it's too heavy on one side of your labels than the other. Of course, right within this, you can do quick modeling. So if you want to do quick predictive models within that, and these are all from the GUI. They're all built into the user interface. So it's really just a matter of getting some familiarity with your data with the Canvas tool. You can run models and get quick results, and then if you decide, okay, I do need to hand this over next stage to SageMaker, it's a one-button push, and the Jupyter Notebook that was used to create these samples in Canvas, once again, without any coding, can then go as a Jupyter Notebook to your data science team. So they can pick up where you left off, they can get all the trial results from your preliminary training, and you can move on to the next step. So when we take a look at some of the benefits of having this kind of approach to training and deploying models using SageMaker, well, some of these are pretty obvious. To use Trisha's expression, you want to fail fast because that's how we get to our goal, right? When I'm coding at home, my daughters always ask me, you always look angry when you're coding, but I thought you loved it. Now, that's because coding is just blocker after blocker after blocker to success, right? That's fail fast. So if you take a look at some of these really heavy-duty models here, a BERT model, Hugging Face Roberta model right here, we have anywhere from 27 to 54% time optimization using these same techniques that I just described. All right, so that's time optimization. It's also cost optimization. But what about governance? Using SageMaker tools, you can get visibility into the bias that might be in your data. When you begin to train, you could see how some of those results are coming. So when you choose your model to put in production, you have all those metrics there, and they're easy to share right from the SageMaker notebook and to print out and share with other colleagues when you're making those hard decisions of, am I optimizing for latency or throughput or cost, or perhaps for a particular customer class that you have, you can get all those metrics. We have two tools that are built into SageMaker that help enable that process. One is Clarify, which has a number of, it's really a curated set of responsible AI tools, I guess is the term that's used now, that look for all kinds of bias in your data. And we can produce metrics not only when we're training the data, but when that model goes into production. So as you put your model in production, we've all had this experience, right? Human behavior changes once people detect that they're interacting with a machine. We get it when we do customer service calls all the time, and we get a chatbot, for example. Well, it's the same thing almost anywhere ML models are put into production, because that data wrote the code. You put the code into production, and you will begin to see changes in behavior in the data that's coming in. That can have a number of consequences. You may need to rerun the model. You may need to retrain regularly. You may need to bring data scientists back in, human in the loop, for example. So all of that is tracked, it's audited, it's auditable, and it can ultimately be used then to make better decisions about how those models are going to work in production. So the next step is, what about ML ops, right? It's a really important term right now. There's a number of aspects of DevOps that are very different when it comes to working with machine learning models. First of all is cost, right? So we have to keep track of how much our models are going to cost in production. We have something called the inference recommender. So once you've trained your model, well, while you're training the model for that matter, you can automatically determine how much that model is going to cost in production at various stages of deployment. So when you run that inference recommender, it goes in, you can get these costs. You can also see alternative costs where you to deploy those, for example, on different instance types of systems. So operating at scale requires a number of tools for inference. Inference is 70% of the costs for all of your successful machine learning models. I think that's a very conservative estimate because that's why we do this in the first place, right? Real time is obviously key. If you were checking your phone while we were chatting here, maybe checked your bank balance. I happen to know that a lot of those banks have maybe 6 customized models that were just fired up while you're taking a look at some of the options at your bank. That's what happens today. That's real-time inference, but the customers could have millions of models laying at wait, ready for that. And they may not need to run at that moment when you touch that particular screen on your phone. That's where batch transform comes in, where you can process large data sets that produce some of that data that might be not necessarily used for real time. Asynchronous inference is a real important critical step. It sort of fills this gap between real time and batch and what can just be done sort of serverless. When I say serverless, if you're familiar with Lambda, we have Lambda services that just do compute serverless. Well, we have serverless ML right now. So what that is you can have, once again, for each customer, maybe dozens of these models. You will sacrifice a little bit for the first call on that particular model once it comes up, just like you do in Lambda, but subsequent calls are more or less instantaneous. And that middle gap, the asynchronous inference, is really for, once again, these large data sets, large payloads, more than a gigabyte. But you're in an app, you're running real time, you can have the little spinning wheel for the customer while they're waiting for that to process, and then you move on. And it's all really easy to sort of integrate. All right, so that's the SageMaker picture. Thank you, Trish.
Thank you, yes. So let me just recap for where we've been, because this is important. So you're preparing your data in Vantage at scale with really fast processing and parallelism. That is being automated. So your features are going to continue to be available for those sustainable models. And then once you're ready to deploy, we have integrations that work as well. You don't have to copy your data over to Sage to S3 buckets. You can also connect with the driverless, with the Teradata ML Python package. It also has a driverless connection to the database. So you could actually work with it directly there. Once you have that data prepared, you're bringing it over to SageMaker to develop and train your models. And now you have your model, which you can deploy with an endpoint, right? You can access that endpoint from APIs directly from the database, from the Teradata Vantage database. So when you put it into production, you don't have to move data back and forth anymore. It's already there. It's already been prepared. And that's one way that we are allowing these models to be implemented at scale and very quickly. So this is the integration flow that we have with where you prepare, transform your data in Vantage. That's on the very left. And whether you're using the feature store or an analytic data set or even the native object store and combining those, You're going to transform that sample data set, a significant size that's going to be useful for training in a SageMaker, whether it's an open source or whether it's a SageMaker algorithm. You train and build them there, and then you're going to push that ML model back to Vantage. So the way we push it back is because we've serialized it into a predictive model markup language, or a PMML file, or an Onyx file, or H2O AI, a Mojo file. Bring those back into Vantage, install it into the database as a blob object, and it's accessing that machine learning there. And we have interpreters within the Vantage system that's going to understand those machine learning algorithms and be able to produce the results and scoring and inference. We also have these API integrations in the works, so I'm excited about these. So we have, we're creating these APIs to be able to leverage things like Amazon Forecast, Fraud Detector, Augmented AI, and Amazon Comprehend. I'm super excited about that because I know I work with the healthcare clients, and I know that in particular Amazon Medical Comprehend is something that we're very excited about working with. So let's transition. We'll spend a little bit of time talking about some of the use cases that we're seeing out with our customers. So in healthcare, I mean, I work with the healthcare accounts, so this is what you're going to get from me. We have customers that are creating propensity models, basically, making patient 360, and if you're not in healthcare, it's a customer 360, same thing. It's a propensity to have a certain disease or condition, or have a propensity to do, whatever thing that you're trying to do. But it's for customer or patient segmentation to make the personalized experience for our patients. Same thing with our customers, whether you're in retail or other. We're seeing use cases where, and these are our top ones that we see often. They're working with supply chain prediction, of course, recommender engines for healthcare network optimization, meaning which specialty provider should I go to. Resource utilization. So as we all know, during the pandemic, especially, resources at a hospital have been stretched. Prior authorizations, cost prediction, point of care, those are some of the use cases we see. In this particular one, we had a large healthcare network. I mean, millions and millions of patients. So they had this very fragmented, siloed systems where they have many organizations trying to come together. Well, we were able to help them bring together over 40 different data sources amongst all of their organizations within their network. So that they had that one view of the patient, and they could follow their patient in their journey, in their care journey, through a specific condition. You know, this is the type of data integrations that we're good at. And then what did they do with those? Well, they created basically recommenders for their patient portals. To say, hey, I noticed you were looking at this, you filled out this assessment, hey, have you considered going to this specialist? Those types of things, just to improve their care journey. And that's been something that is, helping them to increase their revenue incrementally, but even for one service, it was like a $90 million increase. So that was pretty spectacular for them. All right, so I'm going to hand it over now to Scott. We're going to finally let you talk.
Thanks. I do need to apologize, though. I'm not in healthcare. I'm not a data scientist. I'm not a technician. I'm the business guy. I've only been in manufacturing for about 44 years, and I still haven't earned a nice black golf shirt. So, again, I apologize for that. I don't really fit in up here. But no, we're going to talk about ML in manufacturing what some of the leading use cases are, and in the interest of time, probably only a couple of these. But these are probably the leading 6 areas that we see in our customer base right now where ML is being used: predictive maintenance, predictive failure, quality and yield on the shop floor, supply chain including forecasting, demand planning, energy consumption forecasting in the plants, and sustainability is really starting to come on strong. Digital twins, which I know I was in a session at 9 o'clock this morning that talked about digital twins. And then, of course, all the new latest and greatest smart Industry 4.0 manufacturing techniques also. But in the predictive failure, predictive maintenance, right, it's really important that data is being used to look at all the history that has taken place and all the activity that's taken place on the machine, the current demand forecast. Everything is going to be able to go into identifying what could be the trigger points for a failure. That's the scheduled maintenance records, any kind of unscheduled repair that's been done. We have customers in the aerospace industry that use a lot of text and unstructured data, log data as well, and any other kind of usage information. In this case, in the aerospace area, it's the flight logs and flight patterns and pilot behavior, weather, altitude. It's basically every piece of information that you can get about how that piece of equipment is behaving in the field to help build the models to predict that failure. And ML capabilities, along with SageMaker, can identify those patterns that you can use and those models that you can use to build those predictive algorithms. Lots of benefits in manufacturing, right? Reduced unplanned downtime, diagnostic-based repair. So if the models can help you determine that X part is going to fail, they'll know why, and they'll know theoretically. We have a customer that we're working with that is tracking behavior of over-the-road trucks and the engines on those trucks, and they're able to diagnose the problem with the engine while it's still driving down the road after the check engine light went off. And they're actually looking at saying, okay, you're out on I-95 somewhere, you need to be in a service center within the next 24 hours. The next closest service center on your route is in, somewhere in Florida, and we can get you in there. They have the part. We can do the repair in 3 hours, and we can get back on the road with the minimal kind of downtime for that truck on the road without impacting its customer service. So those kinds of things, to be able to do that diagnostic repair, diagnostic analytics, is helping improve service life and customer service for those products. Obviously, lengthening the surface life of a product like that, better supply chain inventory planning. As I said, they can tell you that dealer that you're going to take that truck to actually has the repair part you need. Otherwise, we would have sent you to a different one. And then just overall planning capabilities for where inventory should be distributed across your network, those kinds of things around predictive maintenance. I know that in our airline and Air Force customers, it's understanding what kinds of planes are flying where, on what basis, and where the parts should be based on their failure records and their planned maintenance records, where we should optimize that inventory. So it becomes a much bigger picture than just this thing's about to fail. It really affects the entire ecosystem of the enterprise, and these techniques that we're using with SageMaker, and we're going to talk about one here in a minute, are just beyond compare with what we could just do just a few short years ago. Engine predictive failure. We have a heavy equipment manufacturer that is in the mining business, and any unscheduled downtime is literally money. If they're not hauling dirt on one of those big dump trucks, then that dirt's not going to the processing plant and they're not finding gold. So if that truck goes down unplanned, they're losing revenue by the minute. So it's a very, very high value prop to be able to predict the failure of those engines, that equipment. We use data on Vantage with AWS for the primary data on the vehicle, the maintenance history, any sensor data that's coming off the equipment, to build those predictive models and then deploy them in the field so that they can avoid that unscheduled downtime. Predictive quality, we're going to talk about a specific use case here in a second. This gets to the point where we can do deep root cause failure analysis of any kind of quality and yield problem. We've had a customer that makes hydraulic hoses, and we were looking at everything associated with that hose as it was going through the manufacturing process to ensure there were no areas on that hose that may puncture out in the field or lose, because it's under high pressure, and it could, literally pop in the field. And so being able to understand things like overlay wraps on the wire that's going through the machine being built, or the temperatures that's going through the autoclave, was it set right? And one of the things that's really important when you're looking at all the sensor data that's coming off the manufacturing floor to predict a quality problem or a yield problem is you also want to look and see what the operator is doing on the machine. Did he just tweak the machine because he heard something in it that didn't make sense? And when he did, he completely violated all the rules of the predictive model that we just spent, days and weeks building, that just blew it out of the water, and now you got to start over from scratch for that production line for that day. So it's understanding the human intervention and what damages that causes after you've put the predictive models in place to tell you how to run that product in the first place. So one of our customers, joint customers with AWS in an industrial cloud, is a big automobile manufacturer, and they have put a predictive failure model in place on the robots on the shop floor. Prior to doing this, they were able to inspect 1 out of 1,000 spot welds on every vehicle that was produced. And you can see some of the numbers there, 1,300 plus vehicles a day, 7 million weld spots a day, right? Deployed over 42,000 analytical models to identify each and every weld as it was going down the line to ensure the welds were good, 100%. Right? And you can see where there are good welds, borderline welds, and bad welds. It's a function of the resistance curves and time and the temperature of the weld itself. So by doing this, not only did they now inspect 100% of all welds, that data goes out to the cloud, goes through the models, identifies the data by weld spot, and then reports back to the operator in less than 10 minutes where there's a vehicle and what weld is possibly bad, and go inspect it physically and make a decision on the line whether or not to rework it, to pull it off the line, do it while you're going down the line, whatever the case may be. But on 100% of the welds, and again, 7 million welds a day, they're able to identify the individual welds that are failing. So again, following the 1, 2, 3, right? They had to prepare the data, they had to train the models, over 40,000 different models, and they had to deploy the model in a cloud, an industrial cloud, AWS cloud, and again, using QuickSight, getting that data back to the operator within 10 minutes. Sorry I'm going through this, but we're about to get the yellow light here, so going to be a little quick. The benefits of manufacturing are pretty obvious, right? If you look at this list, it's to improve the quality on the shop floor and process-driven loss reductions, cost reductions on the shop floor through preventative and predictive maintenance, boost in capacity, right? If I wasn't able to inspect 100% of the welds, I may not be producing as many vehicles because I got to make sure the quality is there. Now that I can inspect 100% of the welds, I can ramp up the production lines and we can rock and roll, right? The ability to scale. We're going to take that model for those welds, and we're going to go across multiple lines in that plant and then multiple plants in that company across multiple countries. So the scalability factors there, the ability to do that very quickly and still return results within those few minutes of a weld spot are critical going forward. That helps everything associated with inventory up and down that line, planning and forecasting, supply chain. It improves, obviously, quality control. I mean, it is just, again, that enterprise value of being able to use those models on one specific area, but then apply that across the enterprise for overall cost savings in the organization. So with that, you know, there are a couple kind of go-tos we want to talk about.
Yeah, so we've talked a lot about this and shown you a lot of slideware. If you want to come see it in action, come to the Teradata booth in the tech showcase. We'll show it to you. We'll show you how fast it is. Come on down. Number 2, if you have dinner plans tonight, cancel them. Come with us. There are folks in the audience with cards. I forgot to bring them up here. They have cards with a QR code to sign up for dinner at Carbone's here in Aria. It's going to be a good time because you know Scott will be there. Okay, I'll be there too. I'm kidding. All right. Yeah, there it is. Yeah, you can hold it up. Thanks, Vanna. All right, and then number 3.
Oh, sorry.
One more thing. We've got some virtual hand-on labs or in-person immersion workshops. If you're interested in having those, email us at aws@teradata.com. And with that, I'm going to say thank you. Enjoy the rest of your conference. We'll take questions.
In 4 minutes and 25
until they
seconds.
kick us out. So, any questions?
Okay, thank you very much.
Yeah, thank you.
Have a good show.